B intersection C event is second toss is heads and exactly two heads are tossed in a row. Exactly two heads are tossed in a row. Okay. So what are the events? So second toss is
Yes, sir.
heads and exactly two heads are tossed in a row. So first, let us see this. Second toss is heads. Okay. And exactly two heads are tossed in a row. So this one is okay. So H is there. H,
Yes, sir.
H, H. Next, second toss is heads. In this also you have second toss heads and two heads are there, right? These two. So therefore HHT is also there. Okay, let's see the next one. Second toss is head. In this is striked out because the second toss is not heads. This is also gone because second toss is not heads. This is second toss is heads. And are there exactly two heads? Yes, there are two exactly. These two heads are exactly two in a row. So THH is there. Next, second toss is heads, but no two heads in a row. So this is also out. Okay. Next, second toss. This is also out
Yes,
because
sir.
the second toss is not heads. This is also out similarly. So only these three events are there.
Yes, sir.
Okay, B intersection C. So therefore, what is PB intersection C?
Yes, sir.
It is 3 by 8,
Sir,
right?
3 by
8.
8. Yes, sir.
So therefore,
Yes, sir.
now also, what is PB here? PB we have already found out. PB was how much? PB we have found out to be half. And what is PC here? PC
PC
we
was
have
also
found
half.
3 by 8. PC was 3 by 8. See,
Oh,
PC was 3 by 8. Okay, 3
yes,
by
yes, sir.
8. So now let's see
Yes.
what is the left hand side? PB intersection C, which is 3 by 8. What is the right hand side? Right hand side is PB into PC.
Yes, sir. P of A. Yes, sir.
Now let's check whether they are equal. 3 by 16. So are these two equal? Left hand side is not equal to our right hand side. So since left hand side is not equal to our right hand side, that means PB intersection C is not equal to PB into PC. Therefore, can I say that B and C are independent? No. Hence, since PB intersection C is not equal to PB into PC, therefore B and C are not independent events. Clear? Understood? Yes, tell me fast. Yes, tell me.
Hello.
Tell me what.
Yes, sir.
Okay, so they are not independent. Now, can
Sir,
you
it
tell
is
me?
not equal to LHS.
Yes. So if two events are not independent, what do we call them? What do we call them if two events are not independent?
Mm. Sir, mutually exclusive.
If, as I told you
Mm.
yesterday, if you remember, I told you if two events are not independent, then the question they must be dependent events. Remember this.
Oh. Yes, sir.
If they
Yes,
are
sir. Yes,
not
sir.
independent, they must be
Sorry, sir.
dependent. And when the question of dependent comes, then we talk about conditional probability. Understood? So anyway, we conditional probability
Yes,
will
sir.
come. We will
Yes, sir.
discuss later. So we say that B and C are dependent events. That means one depends on the other. Okay.
Yes, sir.
Let us work the third one out similarly. So first one, third question is check that A, C and A are independent. So first let us find out C intersection A. C intersection A, what is this event? What is the event C? The event C is first toss is exactly two heads are tossed in a row. Okay, and A is the event
It's a
first toss
toss.
is heads. So
Yes, sir.
just
First
connect them,
toss.
with
Yes,
an
sir.
and. Exactly two heads are tossed in a row. Exactly two heads are tossed in a row, and and what is the event A? That first toss is heads. First toss is heads.
First toss is head.
So tell me, in which of the events in the sample space exactly two heads are there in a row and first toss is heads? Let's see. See, in the first one, we have this HHH. Two heads are there in a row,
Yes, sir.
and also the first toss is
Yes, sir.
heads. So this will qualify.
But two will be
So HHH will qualify.
HHS.
Next,
Yes, sir. And then HST.
mm, next this one. HHT will also qualify. This one will qualify. What else?
Yes.
This will not qualify. This will not qualify.
No, yes,
Okay.
sir. Yes, sir.
This one will also not qualify. Two heads are not there in a row. This one has two
Yes,
heads
sir.
in a row, but the first is not a head. So this will also not qualify. So this is
Yes, sir.
also gone. This one, there are no two heads in a row, so this is also gone. Okay. This one, don't have two heads in a row, so this is gone. And similarly, this is gone. So you have only
HST and
HHT.
HST. Yes, sir. HST was there.
HHT. Fine, only two. So therefore, what is
Yes,
PC
sir.
intersection A? Probability of C and
2
A,
by
2 by 8, which is 1 by
yes, sir.
4. So also, what is PC? PC is 3 by 8. If you check above, PC was 3 by 8, right?
Yes, sir.
And
And
PA
PA was half.
was half, right? So now let
Yes, sir.
us check whether these are
It is
independent or
also
not.
not equal.
Yes. So LHS is equal to
Independent.
PC intersection A, which is 1 by 4. And RHS is PC into PA,
3 by 16.
which is 3 by 8 into half, which is 3 by 16. So that means since LHS not equal to RHS,
They are dependent event.
yes, they are not independent and therefore they must be dependent events. That means
Okay.
PC intersection A is not equal to PC into PA. Hence A and B are not independent events. C and A, sorry. C and A are not independent events. Are not independent events. Okay. Now the last one are not, sorry, not independent events. Now let's check whether A, B, C, all three are independent or not. Okay. So first of all, what you
Yes, sir.
do is we find out what event this is. A intersection B intersection C.
A
What is this
intersection B
event?
intersection C.
If you see, A is defined as the event. A is defined as the event first toss is heads. B is second toss is heads. And C is exactly two heads are tossed in row. So this and this and this. So three
Yes.
conditions are there. First toss is heads. And next, what is the event B?
Second toss is head.
Second toss is heads. Second toss is heads.
Two hits are
And
tossed in row.
and finally, you have
Exactly.
exactly two heads are tossed in a row. Exactly two
Yes,
heads
sir.
are tossed in a row. Exactly two heads are tossed in a row. Okay, so let's see which are the event that qualify. First is heads, second is also heads, and two heads in a row. Okay, so let's see what are the events here in the sample space.
Yes, sir.
So this one qualifies, right? HHH is definitely there. Let's write.
Yes, sir.
Next, first toss is heads, second toss is heads. Here, first toss is heads, second toss is heads, and two heads are there also in a row. So HHT also qualifies. HHT qualifies, right? Next, again, first toss is heads, second toss is heads, and two heads qualifies. So this one is out, right? HTH, because first is head, second is tail.
Yes, sir.
This one is also out. Okay. This one is also out. This one is also out.
This one or
This one also out. This one out.
the
Only so
two.
only two events. Yes.
Yes, sir.
So only two are there. Fine. So therefore, what is the probability of A intersection B intersection
A
C?
intersection B intersection C is 2/8,
It's 2 by
1/4.
8, which is 1 by 4. So now we shall calculate the product. Also, first let us write it down. PA is half, PB is half. We had calculated above all
And
this,
PC
and
3/8.
PC is 3 by 8. So what is PA into PB into PC? First, let us write a LHS and RHS.
Yes, sir.
LHS is A intersection B intersection C, which is 1/4. RHS, PA into PB into PC. PA into PB into PC. So half into
PC.
half
Yes, sir.
into 3 by 8. So this is 16 into 2, 32. 3 by 32.
3/32.
Are they equal? They are not equal.
Yes, sir.
That means A,
No,
B,
sir.
and C are also
They
not
are dependent
independent
event.
events. Since LHS not equal to RHS,
Yes.
that means PA intersection B intersection C is not equal to PA into PB into PC. Hence, A, B, and C are not independent events. A, B, and C are not independent events. That's it. That is how you check for dependence and independent, and that is what we mean by independent and independent events. Okay, so this was just a small illustration to show you what actually we mean by independent events. The next thing that I'm going to show you is uh, remember De Morgan's law yesterday I told you? De Morgan's laws. You see these?
Yes, sir. Yesterday
De
we were
Morgan's
saying
law,
about.
A union B complement is equal to A complement intersection B complement, and A intersection B whole complement is equal to A complement union B complement. Okay. Now, as I told you
Yes, sir.
yesterday, that if you have two events, if A and B be any two events connected to a random experiment, connected to a random experiment S, then what do we know? We know that PA union B is equal to PA plus PB minus PA intersection B, right? We know this, right? Now, till your class 11, I had
Yes, sir.
discussed that how to find out PA union B, right? If you know PA, if you know PB, and if you know PA intersection B, then very easily
Yes,
you
sir.
can find out PA union B. But the problem here is that what if
Yes, sir.
you don't know PA intersection B? What if A and B are not mutually exclusive? Not mutually exclusive means PA intersection B is not equal to 0. Okay. Remember, for if events are mutually exclusive, this is very important, which we shall apply each and in most 99% of the problem we are going to apply this. That in this formula, if A and B are mutually exclusive, then this part is going to become zero. That is, PA intersection B has to be zero. Then we simply have PA union B is equal to PA plus PB. Okay, remember this. So if A and B are not mutually exclusive, then we have this formula. But what if I don't know this probability? Then what will I do? Suppose if I don't know this probability, PA intersection B, but I know that A and B are independent events. Okay, if A and B, let's say case one, case one. If A and B are independent events, if A and B are independent events, okay, then what happens in this case? Then we know that PA intersection B must be equal to PA into PB because they are independent, right? So therefore, what
Yes,
will
sir.
this formula become? PA union B is equal to PA plus PB minus PA into PB, right? Only if you know that A and B are independent. If you don't know, then you cannot write this. Understood? They have to be independent events for you to apply this formula. Remember, if A and B are
Yes.
independent events, then PA union B is equal to PA plus PB minus PA intersection B. Second case. In the second case, suppose you don't know that A and B are independent events. Okay. But you want to calculate if A and B are not independent events. Okay. In this case also, if A and B are independent events, not dependent, in this case also A and B are independent events. Then what you can do from this is you can write PA union B is equal to 1 minus PA union B complement. Can you write this? Tell me. Do you remember the definition of complementary events? Complementary event, do you remember? If A and A bar,
Complementary event.
if A and A bar are complementary events, this is you have done in your class 10 also. If A and A bar are complementary events,
Yes, sir. Yes, sir. Yes. I
then we
remember.
can write PA is equal to 1 minus PA bar, right?
Yes.
Similarly, that is the
Yes, sir.
same concept I have applied here. A union B I have considered as one single event. So therefore, I can write PA union B is equal to 1 minus PA union B whole bar. Can I write? Tell me, can I write?
Yes, sir.
Okay. So no doubts here. Now this, remember
Yes, sir.
this case 2 is very, very important. How is it important? Because we will be using this over and over again. Okay. Now what happens? So therefore, we have written PA union B is equal to 1 minus P from De Morgan's law. Can I write it in this manner? A complement intersection B complement. Just check from De Morgan's law if we can write this part. Can I write it this way? Just check.
Uh,
From De Morgan's law,
yes, sir. We can write.
we can write. Now, if A and B are
Yes, sir.
independent events, if A and B are independent events, then the complementary event must also be independent, right? Right or wrong?
Yes,
If
sir.
if A and B are independent event, then the
Yes, sir.
complementary event must also be independent. Then A bar and B bar
Yes.
are also independent events. So therefore, what can we write from here? Therefore, PA union B is equal to 1 minus, because they are independent, PA bar intersection B bar can be written as PA bar into PB bar. Just check. I can write,
Yes, sir.
right? So therefore, what happens?
Yes, sir.
Now, what is PA bar? PA bar is 1 minus PA, right? And what is PB bar? It is 1 minus PB, right or wrong?
Yes, sir.
So therefore, what do you see? That we are able to calculate PA union B even if we don't know PA intersection B. If we only know that A and B are independent events, then we can calculate the probability of occurrence of A or B from this. PA union B is equal to uh, 1 minus PA bar into PB bar. If possible, you can remember this result. We will be using this result extensively. PA union B is equal to 1 minus
Okay.
PA bar into PB bar. Okay, we'll be using this extensively.
Yes, sir.
Okay, so that is what you must remember. Now we come to the problem types that we are going to discuss. There are only a few types of problem that we are going to discuss in probability that come in your examination. Type 1. Okay, type 1 problem, let's say problem type 1. Okay, probability of occurrence probability of occurrence of at least one of the several events of the several events associated with a random experiment. Okay, see from the
Yes,
top
sir.
again, from this result only. What is PA union B? Remember this, A union B is the occurrence of at least one of the events, right? From the last year's knowledge, you know, A union B, A or B. That means at least A or B is occurring. A union B is the occurrence of at least
Yes, sir.
one of A and B, right? So therefore, how
Yes,
will you
sir.
calculate this probability? From this
Yes, sir.
formula only. PA union B is equal to 1 minus PA bar into PB bar. Understood? Now for n events, for n events, now if there are more than one event, then what happens? P E1 union E2 union up till say En is equal to 1 minus P E1 bar, P E2 bar, P E3 bar, and so on. And so on up till PEN bar. Understood? So not only two events, if there are, even if there are more
Yes,
than
sir.
two events, you can write this. Okay. Now let us see how, let us, in order to understand this clearly, let us see one example. Look at this problem, or let's say example. The question is, this came in your ISC also. A problem in mathematics is given. Problem in mathematics is given to three students whose chances of solving are whose chances of solving are half, one third, one fourth. What is the probability that the problem is solved? Question is, what is the probability that the problem is solved? That the problem is solved. Okay. Now remember, whenever you are approaching any kind of probability problem from now on, always remember
Yes.
that you have to define the events. You'll have to see the question first. Keep an eye on the question. I say let E be the event. Let E, let us define the following events. Let us define the following events. What is the first event that you will define? The first event that you are going to define is the question. What is the question here? Let's say E. We are defining the event E. What is the question here? That the problem is solved. So we will define the event, the problem is solved. Understood?
Yes, sir.
See how you frame the events. Keep an eye on the question. Okay. The first event that
Okay,
you're
sir.
going to define is from the question only. The question is find the probability that the problem is solved. So your first event will be let E be the event that the problem is solved. Okay. Now
Okay,
how
sir.
many students are attempting to solve? How many probabilities given? Three probabilities are given and three students are attempting to
Yes,
solve, right? So let us say I define the event A that the first student solves the problem. Understood?
yes, sir.
First student solve the problem. Why did I define? Because I see a probability here, half. Understood?
Yes, sir.
Next event is B. Second student solve the problem. And third is third student solve the problem.
Yes, sir.
Therefore, when is the problem solved? When any one of the students solve the problem, A union B union C,
Yes, sir.
right?
Yes, sir.
What is this event?
Yes, sir.
Any one of, or let's say at least one,
Yes.
at least one, not any, at least one, at least one. See this problem type that I was discussing was at least one. Let us underline this, at least one. So whenever you come across this phrase, at least one, union should come into your mind. Understood? Clear? This is very important. Tell me whether you understood this or not. A union B union C means at least one student solves the problem, right?
Yes, sir.
And at least if one student solves the problem, then the problem is solved, right? That means what is E? What is E? E is the
Uh,
same as A union B union C. If three students are
yes,
solving
sir.
the problem, and if at least one solved, then the problem is solved. That means E, whether I say problem is solved
Yes, sir.
or
Yes.
whether I say that at least one student, it is the same thing, right? Therefore, what do we have
Yes,
to
sir.
find?
Yes, sir.
We have to find PE, right? What is PE? PE must be equal to P A union B union C, right?
See.
Now, what is given here? Let's see.
Yes,
What
sir.
is given here? We know PA, right? We know PA as how much? What are the probabilities given? PA, PB, and PC are given to you,
Uh, yes, sir.
right? So, how much is PA? PA is half, PB is one third, and PC is one fourth. So, half, one third, and one
Yes,
fourth,
sir.
right? So, now based on these PA, PB, PC, we need to calculate PE. Therefore, probability that a problem is solved, probability that the problem is solved, probability that the problem is solved. P is equal to PA union B union C, right? And what is PA
Yes, sir.
union B union C? Again, we shall apply this rule. This formula we shall apply. Understood? What is
Okay.
PA union B
Yes,
union
sir.
C? It is 1 minus P A union B union C
One
whole
minus
complement.
A union B union two
Or let's say,
complement.
and not
Yes,
not
sir.
this way, and write the formula directly. I'm deriving the formula actually. PA union B union C is equal to 1 minus PA bar into PB bar into PC bar. Why?
Yes, sir.
Because here A, B, and C are independent events,
Yes, sir.
right? So therefore, from the formula I can write, because A, B, and C are independent, I can write PA union B union C is equal to 1 minus PA bar, PB bar, PC bar. I've already shown you the deduction, right? You don't need to remember the
Yes, sir.
deduction. You simply remember this formula. If A, B, and C are independent event, then you can apply this formula. Okay, this formula. If A, B, and C are independent events. Okay, this one. Okay. So therefore, what is this? 1 minus, what is, if PA is PA, what is PA bar? It is 1 minus PA, right?
Yes, sir.
And what is P bar? It is 1 minus PB.
One minus B bar.
And what is PC bar? It is 1
Yes, sir.
minus
One
PC.
minus B. One minus
So
C.
1 minus half into 1 minus one third into 1 minus one fourth. That's it. Our problem is solved. 1
Yes,
minus half into, if you take the LCM, this is 2/3 into 3/4. So this three
yes, sir.
cancels. This two cancels. You simply get 1 minus 1/4. So the answer is 3 by 4. Clear?
Yes, sir.
So the language
Yes,
here
sir.
was find the probability that the problem is solved. At least one. So the keyword, remember, here is at least. See here. What is the probability that the problem is solved? The keyword here, as I told you, is at least this one.
Yes, sir.
Okay. Whenever you see this word at least, it means A union B union C, or A union B union C union D, whatever.
Yes, sir.
However, howsoever many events you're talking about. If you are talking about two events, then A union B. At least means A union B. Okay.
Yes, sir.
So this is your problem type one. Next, let us say problem type two. Problem type two. Okay. And what is the problem type two? In problem type 2, you have probability of occurrence of exactly one of the events. Probability of occurrence of exactly one. Remember, there's a difference when I say at least and exactly. Exactly
Yes, sir.
one of the independent events. Okay, when I say at least, I mean union. But when I say exactly, this is what I'm going to do. See here.
Intersection. That means, no?
Huh? Now I'm going to,
So that
what?
means exactly one means
Not
sir, exactly
intersection.
one means
Not
intersection.
intersection. It actually means if A and B be any two events connected to a random experiment, and E is the occurrence of exactly one of A and B. Occurrence of exactly one of A and B.
Yes, sir.
One of A or B. Then what happens? E can occur in two mutually exclusive ways. E can occur in two mutually exclusive ways. What are mutually exclusive ways? Tell me what are the mutually exclusive ways. First,
Uh,
A occurs and B does not occur,
yes, sir.
and B does not occur.
Sir,
A
in two ways,
occurs,
no?
yes, A occurs. This is one way. Either A occurs or B does not occur, right?
Yes, sir.
And what is the set notation for this? A occurs, intersection, because there is an and here, right? See this and. So intersection, B does not occur,
Yes,
right? B complement.
yes,
Understood?
yes, sir.
Or what else can happen? A does not occur
Uh, it does not occur. Yes, sir.
and B occurs, right? That is
Yes, sir. A complement intersection B.
intersection B. So therefore, E can occur in these two ways, either of these two ways, right? And these two are mutually exclusive.
Yes, sir.
Why mutually exclusive? Because see, if this occurs, then this will not occur,
Yes, sir.
right or wrong? Or if this occurs, then this will
Yes,
not
sir.
occur, right? So therefore,
Yes, sir.
that is why they are called mutually exclusive. And what happens when events are mutually exclusive? Then we can add the probabilities, right? Therefore, E must be equal to A intersection B complement, this one. And because of this OR, we have a union, A complement intersection B, right?
Yes, sir.
And these two events both are mutually exclusive. That means what can we write? PE, the probability of E must be equal to PA intersection B plus PA complement intersection B, right? Why? Because
Yes,
remember,
sir.
as I told you, that P x union Y, what is the formula? Px plus Py minus Px intersection Y, right?
Yes, sir. My
If x and y are mutually exclusive,
yes, sir.
if x and y are mutually exclusive, then Px intersection Y must be equal to 0, right? So therefore, what can we write?
Yes, sir.
Px union Y must be equal to Px plus Py.
Yes, sir.
And out here, this event, A union B complement, and this event are mutually exclusive. Therefore, we can add up the probabilities of this and this. If you consider this to be x, and if you consider this to be y, then can you write Px plus Py?
Yes, sir.
So that is why I've written PA intersection B complement plus PA
Yes,
A
sir.
complement intersection B. Very, very important this concept. Okay.
Yes, sir.
We shall be applying this concept also. Type 2. This is a problem that comes in your examination. So therefore, what can we write? Hence, what is the probability of E? It is P A intersection B bar plus P A bar intersection B must be equal to PA into PB bar, because A and B are independent,
Yes.
plus if A and B are independent, then A and B bar must be independent, and also A bar and B must be
Yes.
independent.
Yes, sir.
Since A and B are independent events. Clear?
Yes, sir.
Now, what is PB bar? What is PB bar? 1 minus PB. And what is PA bar? It is 1 minus PA into PB. That's it. Now you can calculate, give the if you know the probabilities of A and B, PA and PB, then you can calculate. Let us see one problem, one example from this type of problem type. Example. Look at this. The probability that a student A passes the examination, the probability that a student A passes the examination is 3 by 7. Okay. And of student B passing the examination is, and student B passing is 5 by 7. Assuming the two events. Okay, fine. Let's not write this. Okay, it is not given in your question. Find the probability
Okay.
find the probability. Keep an eye on the question. Okay, read the question very carefully. Probability questions. Find the probability of
Yes.
number one. Only A passing the examination.
Only A passes.
Only A passing the examination. Only A. What do you mean by only A? What do you mean by only A?
Sir, only A means, sir, A union A intersection B complement.
Exactly. Because only A means A passes and B fails. Understood?
Yes, sir.
And the second
Yes, sir.
question is only one of them passing the examination.
Yes, sir.
Okay. So let us define the event first. Let us first see the question. What is the question for the first one? Let us define the following events. Following events. First, we shall define the event that A passes, right? Student A passes, right? Second, we shall define the event
Yes,
that,
sir.
see, why haven't we defined the event according to the question yet? Because there are two parts, right? So we'll define the main
Okay.
event we'll define later when we'll be doing one and two. These two are applied to both one and two.
Okay.
Okay. So A B will
Okay,
define
sir.
the event student B passes.
Student pass B.
Okay.
Yes,
Next, I will see the first question. I will keep a keen eye on the first question. The first question is that only A
sir.
passes. So let E be the event that only A passes. Or let's say let E1 be the event because we need E2 also for the second one. Let E1 be the event that only A passes. Okay. Now E1 can occur only in one way. E1 can occur only in one way. And what is that way? A passes and B fails.
Yes, sir.
And what is this event? What is this event? A
A,
intersection,
A intersection.
right? So therefore, E1 is the same as A intersection B complement, right?
Yes, sir.
That means PE1 must be equal to PA intersection B complement, right?
Yes, sir.
Which we can write now
Yes, sir.
PA into PB bar. Why? Because A and
Yes,
B are
sir.
independent events. Why are A and B independent events? Because see, student A, student B, you and Amir,
Yes,
whether
sir.
you pass or fail, you are independent, right? Amir passes does not mean you will pass, right? So these two have to be
Yes, sir.
independent events. So A and B are
Yes, sir.
independent events. That is why I can write PA intersection B bar is equal to PA into PB bar. So this is PA into 1 minus PB. Now what is PA? How much is probability of passing of A? Here PA. Probability, let us look at the question. What is the probability that A passes? 3 by 7. So PA is 3 by 7. This is given to you, right? And what is PB? That is 5 by 7, right? Let us write it here only. Student A passes. So therefore, PA is equal to 3 by 7 and PB is equal to 5 by 7, right? So now we shall just put it here. Hence, PE1 is equal to 3 by 7. Just put the values in here. PA into 1 minus 5 by 7. Let me put a single bracket. That means 3 by 7. Take the LCM, you'll get 2 by 7. That means 6 by 49.
Yes, sir.
This is the
Yes,
first
sir.
answer, that only A passes. Okay, next. What is the next question? We frame the event according to the question. What is the next question? Only one of them passes the examination.
Sir,
So let E2 be the
yes, sir.
event.
Sir, here we will have two cases, no?
Yes, yes.
Sir, in the second part, there will be two cases.
Two cases. What kind of cases will they be?
Sir, the first cases is the A will pass, but the B will not pass.
Okay,
And
fine.
the
But
second case is yes, sir.
but
Hello.
they will be must be mutually exclusive, right?
Yes, sir.
Because if one occurs, the other cannot occur. If A passes and B
Yes, sir.
fails, okay, this is one
Yes.
different possibility. And if A fails and B passes, that is a different possibility. They cannot occur together, right? So they are
Yes, sir.
mutually exclusive. So let E2 be the
Yes,
event
sir.
that only one of them um, passes
Passes.
the
Passes the
examination,
examination.
right?
Yes, sir.
So E2 can occur in two mutually exclusive ways. Two mutually exclusive ways. What are those mutually exclusive ways? First one is A passes and B does not pass.
Yes,
A
sir.
passes and B does not
B
pass.
does not.
What is this event? A intersection B complement.
Intersection B complement.
Or
And the second part,
A,
yes, sir.
A does not pass
But B passes.
and B passes. Not but, and B passes. So this is A bar
Yes.
intersection B, right? So what happens? This event E2, this just underline two mutually exclusive so that remember. E2 is nothing but A intersection B bar, and because of this OR, we have a union A bar intersection B.
Yes, sir.
That means what is PE2? It is the sum of the probabilities of these two events because these two are mutually exclusive. PA intersection B
Yes, sir.
bar plus P A bar intersection B, which is PA into PB bar plus PA bar into PB. right? Why? Because A and B are independent events.
Yes, sir.
Right? So therefore, which is equal to PA, and what is PB bar? It is 1 minus PB. And what is PA bar? It is 1 minus PA into PB. That's it. Now just put the values. What is PA bar? In fact, PA here is 3 by 7
Yes, sir.
and PB is 5 by 7 plus 1 minus PA is 3 by 7 and PB is 5 by 7. So we'll simply calculate this.
Yes.
You can calculate this. You'll get 26 by 49. Okay. Not wasting time calculating. Clear?
Yes, sir. Yes, sir.
So let us do the next problem. Next problem type, in fact. And I'll conclude with this. Just another 15 minutes. Okay. The next problem type here is problem type 3. And this is also important, which is, in this case we shall see repeated trials, or it is also called drawing with replacement. Now what do you mean by drawing with replacement? Suppose a bag contains few balls, right? And if I'm drawing one ball,
Yes, sir.
okay, and then I'm drawing the next ball, but what I do is, before drawing the next ball, I put back the first ball and then I draw the next ball. Understood?
Yes, sir.
That is what is called drawing with replacement. There is another called drawing without replacement. In drawing without replacement, what happens? Suppose that the bag contains certain number of balls. I'm drawing out one ball and then I'm drawing out another ball. So when I'm drawing out the first ball, I'm not keeping it back in the bag. Understood?
Yes, sir.
Before the second drawing, I'm not putting the ball back in the bag. That is called drawing without replacement. In this case, we are talking about drawing with replacement. What does drawing with replacement mean? That suppose I'm drawing two balls, one after the other, one ball and then the next ball. But after drawing the first ball, what I do is, after drawing the first ball, I see the color of the ball. Okay, red ball. Fine, no problem. I note the color and then I put it back. And then again, I draw the next ball. Okay, understood? This is called drawing with replacement. This is called repeated trials or drawing with replacement. Why repeated trials? Because we are repeating the same thing, right? Because we are replacing it. Okay. Now, in case of
Yes, sir.
repeated trials, let us understand first the meaning of trials. Trials means a random experiment in which there are only two outcomes, success and failure. In which there are only two outcomes. What are those two outcomes? Success and failure. What can be an example of success and failure? Suppose I'm drawing out two balls from the bag.
Sir, for example,
Hmm. Tell me. Tell me.
yes, sir.
What were you saying?
Hello, sir. For example, in the basket, uh, I have 10 balls
Hmm.
of three different colors,
Hmm.
and at the when I am taking on the first ball,
Hmm.
when sir, I forgot.
See, uh,
Sir, can you explain?
as from the same example only, from your example, suppose there are three colors. Okay, three colors. Now what happens? Suppose the three colors are red, white, and black. Okay, three colors. Now see,
Yes.
when I am drawing out a particular ball, suppose I am drawing out a red ball. Okay, then what I'll do is I'll say if I draw out a red ball, then I'm successful. If any of the colors like black or white comes out, then I'm unsuccessful. Then it is called a failure. Understood?
Yes.
Suppose if I'm drawing two balls, then what I consider a success? Suppose I consider a drawing of a red and a white ball as a success. Then if I draw out a black ball, then it is my failure. Understood?
Yes, sir. Yes,
Suppose
sir.
in the tossing of three coins that I'm tossing. Suppose if I
Yes.
consider outcome of three heads to be a success. Suppose if I get three heads, then I'm successful. If I get any other
Yes.
outcome, HHT or THH, then all other outcomes are failures.
Sir. Yes.
Understood? So that is what. So
Yes,
let
sir.
us take an example. Let us see in terms of an example. Let us consider the tossing of three coins simultaneously. Simultaneously. What should be a sample space here? Let us write down the samples. We have actually written the sample space already. Sample space in the first example that I did, HHH, right? HHT.
Yes, sir.
Be very clear with this, okay? Success and failure. HTH, HTT, THH, THT, TTH, and TTT. Okay. Suppose getting three heads is considered a success. Getting three heads is considered a success. Understood?
Yes, sir.
Otherwise, a failure. So there are two outcomes. Suppose I define,
Yes, sir.
let A be the event, getting three heads. Then A is the event of a success, getting three heads. And another event that I define for failure, not getting three heads. Not getting three heads. Now, can you tell me the probabilities here? If you from the sample space, what is PA? See how many outcomes are there? There are eight. So probability of getting a success is A, right? Three heads. This is success.
Yes, sir.
Let me write it down.
Is only one,
This is a success,
1/8.
and this is a failure,
Yes, sir.
right? PA is 1/8. Then what is the probability of failure?
Yes, sir.
This is three. This is 7/8, right? This is 1 minus PA,
Yes, sir. 7/8.
which is 1 minus 1/8, which is 7/8. Right or wrong? So therefore, whether I write B or
Yes, sir.
whether I write A bar, it is the same thing. Understood?
Yes, sir.
Now, did you understand
Yes, sir.
concept of trial? Trial simply means success and failure. Now, I can consider getting of two heads a success. Suppose if I say that two heads are success, then what will happen? What are the events that will give me success? This will give me a success. This will give me a success. This will give me a success. This is failure, right? Because
Yes,
only
sir.
one head is there. This is a success. This is a failure. This is also a failure. This is also a failure. So if I define
Sir, this
A as my event of
sir,
success,
four
getting two
four
heads, then it is
by
4/8. And then what is PA bar? That is the event of failure.
yes,
It
sir.
is 1 minus 4/8, which is half. This is also half, right?
Yes, sir.
So that is what we mean by trials. In
Yes, sir.
fact, the exact word is Bernoulli trials. Okay, very, very interesting. It was there in your syllabus, but now it has been removed. Okay, Bernoulli trials. These are called Bernoulli trials. Very, very interesting concept of Bernoulli trials. Anyway, so the the
Which
point that I'm
trials?
Bernoulli trials. These trials are called. You will be studying in your graduation. This one, Bernoulli trials. Understood? Bernoulli trials. So, in this case, what happens? What is the probability of success? What is the probability of success? Suppose if I want to say what is the probability of n successes in what is the probability of r successes in n trials? Let p be the probability of success in each trial. In each trial. Understood? Each trial means you understood what we mean by each trial. For example, here three heads are there. Sorry, three coins are tossed. Right? Here three coins I am tossing.
Yes,
Right?
yes, sir.
Each trial is tossing of one coin. So there are how many trials? Three trials. First trial, tossing of the first coin. Second trial, tossing of the second coin. Third trial is tossing of the third coin. What is the probability? If I consider the probability of head a success, if I consider the probability, appearance of head a success, then what is the probability of success in a single trial? Half, 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 isn't it?
Half.
Yes, in
Sir,
each
not
trial.
understand.
Suppose there are three coins I am tossing. Let us say there are three coins. I'm tossing these two coins. These three coins I'm tossing. Okay. These three coins I'm tossing. In this, I can
Yes,
get a
sir.
head or a tail. Probability of, if I
Yes, sir.
consider the appearance of head as success, what is the probability of appearance of head here? Half. What is the probability of occurrence
Yes,
of
sir.
head here? Half. What is the probability of occurrence here? Half.
Yes,
So,
sir. Half, half.
so
Yes.
P is the probability of occurrence here. P is the probability of occurrence here. P is the probability of occurrence here. Okay. Similarly, let us coming back to this. Let P be the probability of success in each trial, and Q be the probability of failure. Q be the
Then 1
probability.
minus half.
Yes. Q be the probability of failure in each trial. In each trial. Therefore, Q must be equal to 1 minus P, right? In fact, when I'm tossing three coins, if the probability of success in each trial is half, what is the probability of failure? 1 minus half, right?
Yes, sir.
1 minus half. 1 minus half, right? So question is, what is the probability of, in fact, therefore, hence, the probability of n r successes, probability of r successes, probability of r successes, probability of r successes in n trials, probability of r successes in n trials is equal to p to the power of r, because the probability of success in each trial is p, r is associated with
Yes, sir.
success, and q to the power of n minus r, because in n trials there are only r successes. So how many failures? N minus r failures, right? So this is probability of
Yes,
r
sir.
successes in n trials is this. Understood? P to the power of r, q to the power of n minus r. Okay. So
Yes, sir.
uh, just give me a minute.
In n number of ways.
in NCR ways. We can select our successes in NCR ways because the total number of trials is n. So that is why this NCR
Yes,
is
sir.
there. Okay. Now
Sir, what
remember
is
this.
P to the power R into Q n minus R? That one I have understood.
What? Tell me.
Sir, that one P to the power R into Q n to the power R and
What
n
happens?
minus R. That one I haven't
The
understood.
all these trials are independent, right? So S, suppose you have four trials. Okay. Success, failure, success, success. Suppose this. Okay. Now this is the probability
Hmm.
of this is P. The probability of this is P, and the probability of this is P, and each of this is independent. 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 So what is the probability of success? P into P into P, right? And you have one failure also, F. So into Q. So what is the probability of this event? This one, P cube Q, right?
Yes.
But the problem is that success
Q.
can occur in any order,
Yes,
right?
sir.
It can also occur in this order, SSSF. It can occur in this order, or it can occur in this order also, SSFS. Any order it can occur, isn't it? So if
Yes,
I'm
sir.
talking about three successes
Yes, sir.
in four trials, that means this three successes can be selected in four C3 ways. Now you
Yes, sir.
understood.
Yes, sir.
So that is what. Remember the formula. You don't need to remember this. Okay, just remember the probability of R successes in n trials is NCR P to the power of R Q to the power of n minus R. Okay, I'll stop here for today. Okay, and
Yes.